Viewers, welcome to my channel. Our today's topic is dynamics. Viewers, dynamics is a branch of physics in which we study the effects of forces on bodies. This branch of physics is known as dynamics. Now, to further proceed on, first of all, we will define what is force. Viewers, force is an agent that produces sometimes or tends to produce, stops sometime or tends to stop motion in a body is called force. Means that agent which stops a body or tries to stop, moves a body or tries to move a body is called force. For example, if we want to move a object and object is very heavy, although we apply force but we cannot move it. Here what we are doing, we are trying to move it. Force is tending to move an object, but still force is being applied. Similarly, we cannot stop applying force to a moving vehicle. However, we try to stop it. This agent that we apply on the vehicle to stop it, or we apply on an object to move it, this is called force. The force changes or tries to change the state of motion or rest of a body. Viewers, force is placed in vector group of quantities. It is a directed quantity, so it is called a vector quantity. Its unit is Newton. Force is measured in the units of Newton with the symbol N. Now, laws of motion is another very important topic of dynamics. What are these laws of motion? A famous scientist, Newton, studied the effects of force on objects and presented his finding in the form of his famous 3 laws called laws of motion. Now, let us discuss them one by one. What are these 3 laws of motion? They are also known as the Newton's 3 laws of motion. First law, they are named as first law, second law, third law. Starting from first law, it states that if no external force is present, it is the first and very important condition of first law that there should be no force. Or we can also say that in the absence of an external force, or when no force is present, what will happen? The law says that a body at rest will remain at rest. This is the first part of the body. First part of the law. It states that if though no external force is there, a stationary body will remain stationary. For example, a glass is placed on your side table. It will remain there forever until someone picks it up or some event drops it down from that side table. What is that event? That is the application of force in any form. When in any form, if wind blows or table is vibrated, then the glass may fall, but by itself it will not fall. A body at rest will remain at rest forever if there is no external force. That is the important condition of the first law. According to the second part of this law, a body in motion will continue its motion in a straight line. If body is moving, it will continue its motion. If there is again no external force, it will continue moving in a straight line forever. Here there is a confusion for some students that when we throw a ball, it will come to rest after covering some distance. So is it the violation of law? No. Keep in your mind the important thing, in the absence of an external force. When we throw a ball, there are some external forces acting on it. For example, the pull of gravity, the friction between ground and ball, or the air resistance. These are the external forces. If they are absent, Newton said, if these forces are absent, a body in motion will continue its motion in a straight line with uniform speed. Now, this law is also known as the law of inertia. Students, inertia is the property of a body or the reluctance of a body to change in its any state of rest or of uniform motion. There are so many situations in our everyday life where inertia is applied. For example, when a person is running and he stumbles against an obstacle, a running person falls in the forward direction. This accident is due to inertia. Lower parts of its body comes to an halt, while due to inertia, upper part of the body wants to continue its motion in the forward direction. As a result, he loses balance and falls in the forward direction. On the other hand, if a car starts moving suddenly, the person sitting in it falls backward. It is also due to inertia. When the car was at rest, the person was at rest, and both want to remain at rest. As car starts moving suddenly, due to inertia, the person upper part of his body wants to remain at rest, while lower part moves forward. As a result, he falls backward. To compensate the effects of inertia in a car, seat belts are provided or neck back is provided to minimize the effects of inertia in a moving vehicle. Now, second law. Weyer's first law says that if there is no force, there will be no change in the state of the body. Body at rest will remain at rest, and body in motion will continue its motion in a straight line. Now, according to second law, if there is a force, what happens? What happens when force is applied on a body? What is the effect of force on a body? According to second law, when force is applied on a body, it produces acceleration in the body. The acceleration produced by this force is directly proportional to this force, magnitude of this force, and inversely proportional to the mass of the body. It means when we apply force on the body, it will produce acceleration. How much acceleration will be produced? It depends upon two things. One is the amount of the force that we are applying, and second is the mass of the body. More the force, more will be the acceleration. This is the direct relation between force and acceleration produced. And more the mass, less will be the acceleration. It is the inverse relation between force and mass. A massive body will produce less acceleration for the same force than a lighter body. For example, if we apply some force on a small car, it will produce acceleration in the car. But if the same force is applied on a truck, a heavy vehicle, then the force will produce less acceleration because the mass of the truck is more. The more the mass, less will be the acceleration. Less the mass, more will be the acceleration for same amount of force. This is the second condition or second reality explained in the second law of motion. Now, mathematically, how we derive or how we relate these three quantities: acceleration, applied force, and mass of the body. Students, physics is the mathematical representation of theoretical findings. So, we can mathematically express the Newton's second law also. Let us start here. According to the first part of the law, when force is applied on a body, it produces acceleration in the body which is directly proportional to the applied force, A proportional to F. And according to the second part of the law, this acceleration is inversely proportional to mass of the body. Combining these two, we get the form like this: A is directly proportional to F by M, or A equals to F over M. Here sign of proportionality is removed. You know, when we remove the proportionality sign, we put a constant there. In this case, constant is 1. So this equation gets the form E equals to F over M. This form is obtained by the statement of Newton's second law. Now rearrange this equation, bringing m on the other side. On the right side it is dividing f. On the other side, when it will move, it will be multiplied with a, and on rearranging this relation we get this proper form of Newton's second law of motion, proper mathematical form of Newton's second law of motion, that is F is equals to ma. It is known as the mathematical form of Newton's second law. Here F is the force, m is the mass of the body, and a is the acceleration produced by this force. If m remains constant, a is directly proportional to f, and if f remains constant, a is inversely proportional to m. Now third law. First law says if there is no force, then what happens? Second law says if there is a force, then what happens? Third law is actually showing a natural behavior. What is that natural behavior? If you affect something, you will be also affected by that thing. I explain it using third law. Statement of the third law of motion is that for every action there is an equal and opposite reaction. Action means force. What is action? The force that one object applies on another. And what is reaction? The force that second object applies on the first as in the response. Now these wording are known as the third law of motion. Can be stated as for every action there is an equal but opposite reaction. Now another important thing to keep in mind is that these action reaction do not cancel each other because they act at two different bodies. It is a common question that is asked in the papers. Do action and reaction being equal in magnitude and opposite in direction cancel each other? No, they do not cancel each other because they act at two different bodies. Action acts on a second body by the first, and reaction is the force that second body exerts on the first body as a response. Though they act at different bodies, so they do not cancel the effect of each other. Students, this third law is applied in most of the cases around Earth. For example, when we walk, walking is according to the Newton's third law. We push the ground, that is our action, and as a reaction, ground pushes us. We push the ground in backward direction, ground pushes us in the forward direction. Similarly, when birds fly, they push the air by their wings in the downward direction, and air exerts force on them in the upward direction. Similarly, propeller of a ship pushes the water in backward direction, and as a result, water pushes the ship in forward direction. These are the examples of Newton's third law of motion from everyday life. Students, thank you for watching this video. Thank you for sparing your time.